Let us try to calculate electric field strength due to infinitely long straight charge wire. Now when I talk about infinitely long straight charge wire, let this be a line, infinitely long straight wire, and let me take a point here. Suppose I take one point here. At this point, suppose I want to calculate the electric field strength. For that, what I have to do, I have to, according to Gauss theorem, I have to take one Gaussian surface. And how the Gaussian surface will be? Gaussian surface will be little bit a regular surface. So in this case, a regular surface which we can take is a cylinder. Now let me take a cylinder. Let me take one cylinder. This is a Gaussian cylinder. And what is the formula of Gaussian? What is the formula for Gauss theorem? It is vector E dot ds, and vector E dot ds, E the electric field strength at this point if I want to calculate. So this is a regular surface, and this surface is has actually three surfaces. In a cylinder, one is curved surface, another is this circle, and another is this circle. So it has in total three surfaces. And if I take a single point or a small area here at this surface circle, and if I take a small area here also at this surface, and if I take a small area of this surface, and now what I have to do according to my formula, it is vector E dot how much? Vector E dot vector ds, and I have to take a surface integral of this. And what will be that at this point? So for that it's a dot product, so it matters what is the direction of E and what is the direction of ds. When we talk about this point, what is the direction of ds and what is the direction of E? If I talk about E, what is the direction of E at this point? At this point the direction of E will be this direction. This will be direction of E. And what will be direction of ds? Because this is a surface, so naturally it will be this side. Why this side? Because ds direction is always perpendicular and outwards. So when this is an enclosed surface, so this will be the outward direction. And in this case, what is the direction of E? This will be the direction of E. And what is the direction of ds? Direction of ds will be the same one, like this. So E and ds, they are the same line here. The angle between E and ds is 0. What is the angle between E and ds here? The angle between E and ds is 90 degree. And see this case for this. So what is the angle between what is the direction of E here? Again the direction of E will be this way only. And what is the direction of ds? Direction of ds will be again it is 90 degree. So what is this? This is E and this is ds. Now what we have to do, we have to apply Gauss theorem here. Gauss theorem says that surface integral of E dot ds. So what is surface integral of E dot ds for this Gaussian surface? The Gaussian surface will be this E dot ds. Let this be ds1, E dot ds1, E dot ds2 and E dot ds3. And you have to add all these three, and this will be equal to what? This will be equal to q by epsilon naught. This will be equal to q by epsilon naught. When you talk about q by epsilon naught, so what is q here? Q is a charge enclosed by the Gaussian surface. What is this? How this q has come? The q has come by multiplying lambda into L. What is lambda? Lambda is actually, what is lambda? Lambda is actually charge per unit length. The charge density, now I can say it is charge per unit length. So if I say charge per unit length, then what is q here? Q equal to lambda into, what is q here? Q will be equal to lambda into L, right? So if I multiply lambda into L, then what I'll get? I'll get the charge enclosed by the Gaussian surface, and that is q. So it will be q by epsilon naught, right? Now let us see how we are deriving. Please check the try to understand. Here the difference is, here they had taken S, the A and B. Surface integral of E dot ds equal to surface integral of A, which is A here, and which is B. This is A and this is B, and there is C also, this is C. Now they are trying to find out the angle between E and ds is 90 degree here. Next one is 90 degree here, but here it is 0 degree. So here this becomes 0 and here it becomes 1, so it is E ds. So what is ds? Ds is this surface, the curved surface, and it will come 2 pi rl. What is 2 pi rl? 2 pi rl is the curved surface of the cylinder, the formula 2 pi rl, right? Now q by epsilon naught equal to lambda l by epsilon naught. Why? Because q equal to lambda l, and where lambda is the line charge density, already we had discussed. Therefore E into 2 pi r l, what is E into 2 pi r l? From where it has come? It has come from the Gaussian theorem, E dot ds. Okay, we had integrated ds, so we'll get this 2 pi r l, that will be equal to lambda into l by epsilon naught from here, right? So next we can rewrite this as E equal to, this will go down, so it will be 1 by 4, 2 pi epsilon naught lambda by r. Again rewriting, we'll get E equal to 1 by 4 epsilon naught 2 lambda by r, and in vector form we'll get this. Now what you have to do is, you have to take a fresh page and try to understand everything first. Then after that you take a fresh page and you derive this yourself in a in the page, and try to find that you can derive it comfortably, confidently, if you have understood everything. And if you have any doubts, please post it in the comment section. We will try to find out the problem. Fine. Thank you.